intervals are certain steps of real numbers. You can have an open interval where a is less than b, and then the open interval from a to b consists of the numbers between a and b, not including a and b. And it's denoted by a parentheses, a comma b. Parentheses. Parentheses are important. So, if we have the open interval from a to b, which is interval notation right here, and then set notation, where x is greater than a and less than b, on a number line, this is a, we have b over here. They would be open circles because they are not included, and then b everything in between. So a real example, we have the interval from 3 to 7. We'd have our number line here, 0, 3, it would be an open circle at 3, open circle at 7, and shade in between. A closed interval from a to b will have brackets closing it off, and this means a and b are included. And you can see by the set notation it says it is equal to a and b. So, for example, if we have a over here and b on the right, they would be closed circles because closed indicates it is included, and we would still shade in between. So, for example, if we had the interval from -1 to 1, it would be a closed circle at -1, closed circle at 1, and shade in between. You can also have infinite intervals where one side you know, such as A, and the other side keeps going. Now if it's an infinite, it will always have a parentheses on the side of the infinite symbol. So if we have this, we could graph it. Here's A. Doesn't matter what A is. On this one, A is not included, so it'd be an open circle, and it goes to a positive infinity. So we draw the arrow, and it continues. Another example of an infinite interval, we could have it going to a negative infinity to 5. And you notice it's closed on the 5 side. So on our number line, that means here's 0, here's 5. It would be a closed circle at 5, and we're going to negative infinity on the left. You can see all the possibilities on intervals on page 9. I highly recommend looking at them and understanding. When we want to find unions and intersections of intervals, we're going to graph each set and then use this to help us find the numbers that fit into the set. So on A, we have the open interval from 0 to 4. And it's going to intersect the closed interval from 3 to 6. Okay, and we know already that intersect means we want what they have in common. So we're going to use a number line to help us out. You could also just list it out using set notation. So we know that on the open interval 0 to 4, we have x, where x, excuse me, we have x in the set where 0 is less than x, which is less than 4. We can graph that on the number line. Open circle at 0, open circle at 4, shade in between. For the closed set notation, the x is greater than or equal to 3 and less than or equal to 6. So we know it needs to be closed circles. There we go, that one's better. Shade in between. Now we see they are overlapping at 3 and 4, but 4 is not included on the blue. So our only solution is 3. Example B is the union of the interval 1 to 4 and 2 6. So we want all numbers that fall into these two. So if we write it in set notation, first one, x is greater than 0 and less than, greater than 1 and less than 4. And we can use both of these numbers because it's an open. So we just use the correct inequality symbol. And then for the closed interval 2 6, the set notation, we have x, where x is greater than or equal to 2 and less than or equal to 6. If we use a number line, the first one, the open interval 1 to 4, I'll do it in green. Open circle at 1, open circle at 4, shade in between. The closed interval 2 to 6, I'll use blue. Closed circle at 2, closed circle at 6, shade in between. So we want all numbers included. So we started at 1, and it was not included, so we would use a parentheses. We ended at 6, and it is included, So we would use the bracket. If you wanted to use set notation for this, we would have x, where x is greater than 1 or less than or equal to 6. So all we did is take out the left boundary and the right boundary and put it into interval and set notation. Let's talk about absolute value. Absolute value is the distance from 0, and it's notated with the 2 lines around it. You have 2 options. It's A if A is greater than or equal to 0, and it's negative A if A is less than 0. You can go over all the properties of absolute value on page 11. The distance between 2 points on a real line or a real number line is given by the d distance of the 2 points A and B. And we are using the interval notation right here. And all we do is take the absolute value of B minus A. So if we have a number line, this is negative infinity. To the right is positive infinity. We have A over here, we have B over here. And you would just subtract it and make sure it's positive by the absolute value. So a real example, if we want to know the distance from 2 to 13, the formula says to take the left boundary and the right boundary. We want to know how far apart they are. Our formula says to take the absolute value of 13 minus 2, which is 11. Exponents are used to make writing the multiplication or division of common bases easier. So a to the n means we have a multiplying itself n times. We have many laws of exponents. If we have a common base, and remember that on any number, this is your base, and here's your exponent. When we have common bases multiplying, we just take their exponents and add them. If the common bases are dividing, I like to think of the fraction bar as a big minus sign, and we know to take the top minus the bottom. When we have a power to a power, so we have x to the m to the n, it's a power to the power, so they multiply. If we have 2 bases getting taken to a power, they both get the power. Be x to the n, y to the n. Same rule applies for the next one. It's a fraction getting taken to a power, so we distribute the power to the numerator and the denominator to get x to the n over y to the n. We cannot have negative exponents, so we jump the line and flip the sign. So x to the negative first goes down below, but it becomes a positive, and we fill in the numerator with a 1. and anything to the 0th power is 1. The exception to having a negative exponent is in scientific notation. We've all seen scientific notation where we have a base times 10 to a power. We know A, this base, cannot be greater than 10 or less than 1. So if we have 1,680,000, we want to write it in scientific notation. We move the decimal place so that it's in between the 1 and the 6. So that becomes 1.68 times 10 to the 6. Likewise, if we're already given a number in scientific notation, we move the decimal this number of places, and because it's negative, we move it to the left to make it a smaller number. 1, 2, 3 times, and we put in 2 zeros to fill.